Welcome to another 2-Minute Tuesday. This week we're going to be discussing when you need a computational fluid dynamic analysis. Let's roll the intro. A computational fluid dynamic or CFD analysis is required when applying a fire engineered solution that is not code compliant, or in other words, is not a solution in line with approved document B. If you're planning a natural ventilation system in compliance with approved document B, you're very unlikely to need a CFD. However, as approved document B only covers natural systems, if you're planning a mechanical system, you're very likely to need a CFD to prove to building control that the system will work. Approved document B does state that mechanical systems can be designed in line with BS EN 12101-6, and if the system is compliant with that, it won't require a computational fluid dynamic. However, it's very challenging to design a system that meets all of the requirements of BS EN 12101-6. For example, you have to have fan sets that will withstand 600 degrees Celsius for 4 hours. For this reason, most mechanical systems are designed and proven with a computational fluid dynamic, as set out in BS 9991, section 14.2.4, note 1, and BS 9991, annex A, A.4. Whilst it is possible to prove that a smoke ventilation system does work without a computational fluid dynamic, by for example testing the system once the system has been fully installed, it's very rarely done in practice for two reasons. Firstly, building control are very unlikely to approve the design without a CFD as it's just too risky. Secondly, if the system were to fail the test, then the cost to rectify the system would actually far outweigh the cost of doing a CFD at design stage. This logic also applies to mechanical car park ventilation systems. However, it's important to remember when modelling car park ventilation systems that we're also considering environmental ventilation to prevent the build-up of fumes, as well as smoke clearance. To summarise, these days CFD modelling is relatively inexpensive, quite fast to carry out, and saves a lot of time and cost at the construction stage. So usually you'll carry out a CFD model for mechanical ventilation systems, but you won't usually carry one out for natural ventilation systems. However, CFDs do more than just tick a box for building control. They also make sure the building has been designed in the correct manner. They take into account things like pressure differentials, soot levels, zone-specific temperatures, flow rates, and much more. So CFDs are important to bear in mind. I hope this week's video has been helpful and that you now understand when and why you might need a computational fluid dynamic. I look forward to seeing you next week, but in the meantime, if you have any questions or comments, pop them in the comments below and I look forward to reading them and getting back to you. Thanks, and bye for now.